All right, so we're back to this house the next day after failing to get the thermal expansion valve or the thermostatic expansion valve to loosen up and function. So we're here to replace it. So we're going to pump it down, go replace the valve, and get everything back up and going for these people. So let's get started. All right, so I'm not sure if this looks like it's been worked on fresh. Or if they always sand their copper. I didn't see it on this one. So that's what makes me think somebody's come back after the fact and changed the valve. And also I can feel that this has kind of been bent on and it's coming from a little more of a funny angle. So let's go in here and see what these new construct guys did. They have had constant problems in this entire neighborhood, which is no different than any other neighborhood we go in. And of course they put this monstrosity of ridiculous flex duct going to distribution boxes, going to more flex ducts. Just see that thing over there. That's a huge mess. There it is. I just don't get that. You know, a plenum that's 8 feet away from the original plenum. You know, I do not understand their logic if they have the opinion that this is logical. I don't understand what they're doing here or why they're doing it. It's just utterly ridiculous in all these houses. And the new homeowners and the people are the victims, but let's open it up and see if it's butchered up or what. Obviously, we're gonna have no choice but to put a valve in it. So we got a new one here with us. Let's see what we got. All right, so it is plain to see they've put a valve in it already once. You can see it's not the factory installed valve that has the little band around it here that holds it. And you can see all of this electrolysis around everywhere. All that nastiness. So it's a shame that a huge corporation at the top of the ladder, such as Trane, would actually sell their equipment to the butchers of the big nationwide chains. This is a Meritage home. I don't know if any of you ever heard of them. You know, and they go through a lot of things to gain specs, such as the spray foam and the conditioned attic or somewhat conditioned attic. You know, they go through a lot of trouble to support their propaganda and their efficiency and etc. And then they install a HVAC system in that fashion right there. I mean, they just stick it in here like a bowl of spaghetti and think it's going to work. The worst thing is they have so much valve failure because of their extremely nasty installation and, you know, practices. They'll run the line sets and let them hang out the wall for months at a time outdoors, and certainly don't weld them up or anything. And then they come back months later and stick the unit on it and expect it to work. So Anyway, we're going to take this valve off and put another one on it. Make another attempt at saving the unit from the abusive installation practices that they performed, and see what we can do. And look at all that. This thing is only from 2016, somewhere in there, so less than 3 years old. Tell you what, boy, I just can't believe what I'm looking at every time I see one of these jobs. Thank God that this company and this builder cannot buy Trane anymore, but boy, did they ever make a mess with them when they did. Eroding our brand name value for sure. Right, let's get it changed out and see if we can get it working right. Okay, we got the new valve in, and a couple of things very important to remember is when you're tightening this flare nut, always use a backup wrench. Now, obviously I can't put both hands on it and hold the camera, but I always have this, this is a 5/8 that fits the actual flare nut, and this 7/16 fits the boss, is what I call it, down here, the flange, whatever you want to call that, the fitting, the flare fitting that's welded on, the flare seat fitting. I call it a boss. And you use two hands and you hold this as backup while you're cranking this. Now, I've seen them at the factory, and they have preset, even on flare nuts here, they have a preset torque wrench, and I have seen them not using a backup wrench, but the torque wrench is set to the torque that's required to flatten the seat and to seat the flare properly, and it'll make a beep. They'll be pulling against it and it'll just go beep, and they just pull the wrench off and leave it. In the field, I just go by feel of the flare. I've done enough flares over the 30 years plus to understand them well. And holding this backup wrench is very important. So I hold this with one hand and tighten this with the other until I feel that we've seated the flare properly. Same thing here is backup wrenches. You take two wrenches to this, take two wrenches to that. I'll get this as snug as I can get it where I can barely move this, and then I'll slip this tube up as far as it'll go, a little over a quarter of a turn, and then I'll crank this down, holding back up with that, and get it facing straight. They give you a little plug on this flare. I don't know why they don't give you anything here, so I end up having to put a little piece of tape on it just till I get it, back through the hole in the cabinet. And I did reinstall the zip tie that goes back there into the plate here, and so it holds it in place. Another thing I do is when I put this new piece of sticky foam, I call it, that comes with this, it won't come off. You don't really need to band over that. Once you've stuck it to itself, it ain't going anywhere. And I take the old piece and I wrap these just to keep these from, I know it's not like that from the factory, and it's a little bit arrogant to think you're going to improve upon a factory design, but there again, the factory design installation is kind of lost when you go back and make an alteration. So as much as I hate it, it is a part replacement, and it's not exactly factory. Again, we try to get as close as we can, but I just do that just to where when that's vibrating and rubbing, it's got that between it. So I'm going to check this one more time just for its seat with both hands, and then I'm going to close this thing up, and we're going to go down there and turn our nitrogen on so we can make this one weld, and then we're going to evacuate this thing and go to town. and I think I will replace that. All right, so now I'm going to show you the proper way to do a pressure test with nitrogen. Now I've turned the regulator back up flat. I always turn this down when I have the flow regulator hooked to it for welding, and I turn it back up just for where it sits in the truck and so forth, and this is how I keep it. So what you don't do, now I've got both hoses hooked to the line set, and I'm going to use my S-Man here, of course, and I've got both valves completely open. Now what you do not do is do not just open the nitrogen and fill the system to a certain pressure and expect it to hold. Even though we were trickling through it while we were welding, the minute you open it and turn it loose, the atmosphere, oxygen, which contains humidity, everything just immediately is back into where you opened it at. So what we're going to do is, obviously I'm going to turn it on, and then I'm going to let's see, I'm going to open both of these valves. I'm going to take this blue hose off. Okay, I'm going to just let it hang open in my hand. So I'm going to turn this on. And I'm going to close the blue side of the gauge. So I've got the blue valve closed, the red valve open, flowing through and bleeding out, and then I let it do that probably 20-30 seconds just to be sure that I've purged all of the oxygen out of the line set and the coil. Then I'll put the hose back on, go ahead and open the blue valve all the way. Now you learn in welding classes and a couple other classes, you learn that a valve of any type should be all the way open or all the way closed if you're trying to do any type of consistent pressure regulation. So I'm going to put this up to where I get about 250, and I'm satisfied with that. I know a lot of people have a lot of different opinions about that, but I'm going to be satisfied with about 250 here. And then I'm going to cut the bottle off. And then I'll go ahead and close both of these valves, and I'll let it stabilize a minute before I expect it to hold still. So what we're going to do is going to make note of where it's at. We're at 252.7 and 0.5. Now if it budges a little bit, I'm okay with that in the first few seconds, but after it sits and stabilizes, which it appears to have done, it should stay without moving at all. So the reason we're getting an accurate pressure test here is with nitrogen, that is because we have purged out all of the oxygen from the system. So as you can see, we dropped 1/10 on the left there, on the suction side. I'm not going to panic about that. I'm going to let everything stay turned off. I'm going to go ahead and unhook my yellow hose in preparation for the next step, which is obviously evacuation. And I'm just going to let this hang right here for a minute. And you see we're back up. So that's not uncommon either. Obviously, if I can't make it hang there, I'm going to screw it back on. That's another opinion I have about your hose ends, is they should never touch the ground. See, and we're dropping a tenth and raising a tenth. But we're stabilizing or coming very close to it. So I'm going to do about a 10-minute nitrogen pressure test here. And I'm going to expect this to stabilize and not to move. So let's complete that before we start our evacuation process. Okay, so where it stabilized at was 252.6 and 0.4. And it's been well over 10 minutes. See, it'll go back up. It went up to 0.5 and back to 0.4. There is some amount of pressure fluctuation going to take place here because even nitrogen is not totally inert and perfect, and we do have the indoor fan running. So right now, you can see. All right, so the phone rang as always. Got the Hillmore going, and yeah, I don't have one of the good rigs with me. The installers have them, so I'm pulling through my manifold and with the standard refrigeration type hoses. So it is going to take about 30 minutes or so for this vacuum to pull down to an acceptable level. So I'm going to watch it. I'm going to let it hit microns, and then I'm going to drive up the road and get me a quick sandwich or a couple hot dogs and an iced tea, and come back down here and check on it. And we're going to let it get down to 500, and then we're going to release it. Definitely slow. It's been almost a minute, and still not actually into microns yet. But it's right on the verge of ready to go. And I'm just going to watch it for a minute or two, and just to make sure it does start dropping. And these sensors are bad to need flushed and cleaned. You know, there's some maintenance on these field piece manifolds that has to be done, but once I see it actually hit the microns, I'll go ahead and take off and grab me something for a makeshift lunch right quick. And then we'll come back and hopefully not have to wait too long to get it down to 500, but it's definitely going to take a little bit with this rig. Yeah, the big old pump doesn't do much. That's a 9 CFM with a busted plastic housing right there. The 9 CFM doesn't do much when it's hooked to, you know, the non-vacuum rated hoses and going through a manifold. So I do always use a manifold, but I don't usually have it going through it like that. Nonetheless, this one's going to take a while. All right, so it took a couple of minutes, but actually did break down into microns. So I'm going to let this thing eat. I'm going to go grab a quick sandwich or something. It's going to be a slow one. It's a big long line set way up on top of the, it's actually 3 stories up because it's in the attic of the 2nd story. So I don't know if 30 minutes is gonna achieve this or not, but it's dropping, so we'll find out. All right, so we've been gone about 35 minutes, which means this vacuum has been running total, I'd say 45 minutes. And I think that's going to be all she can do. So, and what I did was I unhooked the contactor wire so that I could plug the disconnect back in to rob power here. So let's shut this thing down and get this thing going. Go ahead and get this thing fired up. Standing static pressure is, you know, probably relatively close to what we would consider normal. We may have lost a little bit when we pumped it down. Pump down is rarely ever perfect. So, let's let it run a few minutes and we'll set our subcooling. Seeing as how we put a valve in this thing, I guess we're going to go ahead and watch this superheat as we charge it. But let's let it run about 10 minutes first. Alright, so the charge is looking pretty good. I am going to watch it, of course, for a bit. The target for subcooling over here is, of course, plus or minus 3 at 8. So this being a pretty long line, it goes across that attic as well as all the way to the top of it. I'm going to be okay with that fluctuating between 8 to 9. That'll be fine with me. So I have not affected the charge yet, although I did bring a jug of gas over here. But it's looking pretty good at this point, although I'm going to let it run a bit first before I make that assumption that everything is okay, but it's looking pretty good right now. Alright, I'm pretty happy with what I'm seeing. It's been, you know, 8.5 to 9.2 or 3 up and down, and I'm pretty happy with that. It is hot in the house, so I'm not going to get overly excited about suction pressure or superheat. Right now I'm just watching the head pressure and the subcooling. So I'm pretty happy with how this machine is running. And I'm going to button it up and leave it just like this. And these people are going to get home from the Clemson game tonight, and they're going to be real happy. They've been without air for a couple of nights, all camping out downstairs. So this is looking pretty good to me, and I'm going to let it ride. Let's get moving. Alright, and as we established a few minutes ago, we needed a bigger wrench to put on that big one, and had to go grab that. One thing that's important is to always tighten, well, all of these, but especially these Schraders. I do like the fact that Trane uses actual flare caps and that we're seating 2 soft compounds brass to brass on a flare seat there. I do like that, so you don't rely on an O-ring or rely on a Schrader core itself to totally protect us from the loss of refrigerant. So we're up and running and we're out of here. Let's go see if we can make at least 1 or 2 more people happy today. And thanks for watching.